Alright, ladies and gentlemen, we're going to solve some radical equations today. This is part one of our three-part video series of doing some pretty complex radical equations. One of the things about this section is that we've actually done this kind of factoring before. We've done this factoring before, but we did not solve for x. We just did the factoring. So now we get to take it a step further. So if we take a look at these radical equations, what we'll do is step one is, since we don't have like an x squared and an x, what we have here is this weird z to the fourth and z squared. So the first thing we're going to do is we're going to let u, the letter u, equal the middle variable. And for every problem that's set up in this section, if we let u equal the middle variable, then u squared is going to be equal to the first variable. So what that is going to do is that's going to allow us to rewrite this problem as u squared minus 5u plus 4 equals 0. And now what we can do in step 2 is we're going to either factor the problem or use the quadratic formula. Now you'll see that so far in these videos we have done factoring, we have done isolating the square or the square to take the square root, completing the square or quadratic formula. Well, we're just going to do the greatest hits here. Either we're going to factor this or use the quadratic formula, and those are the only two methods I'm going to use here. So the other two are going to be relatively ignored. Now once we factor and use the quadratic formula and finish factoring, what we're going to do is we're going to plug the middle variable back into the problem. So let's just write that out. Plug the middle variable back into u. And then we're going to solve. And we're going to solve that problem. And this is, I know I've just kind of wrote this down here, but I think it's going to be best to actually see steps 2, 3, and 4 straight out. So let's get into this, and we'll have 6 examples that run through these 4 steps. So again, we've actually factored this before back in a previous unit when we learned about factoring some very strange looking problems. So let's now apply this here. So I've got u squared minus 5u plus 4, because what I did is I plugged my u in for z squared, and therefore u squared is going to be z to the fourth. Now I get to factor this. Now this is factorable. There are two numbers that multiply to make 4, and I had to make negative 5. And that's u minus 4, and then u minus 1 equals 0. Now if I solve for these problems here, what I have is I have u minus 4 equals 0, u minus 1 equals 0. So if I move the 4 over, u is equal to 4. If I move this over, this u is equal to 1. Now, I've done steps 1 and 2, which is let u equal the middle and the first variable here. I factored, and now what I'm about to do is plug the middle variable back into u, because these are not my final answers. My final answers are not u or 4 and 1, because I'm going to take that middle variable, which u was plugged into. See, there's my u equaling 6z, or sorry, z squared. So u is equal to z squared. And now I'm going to change that back into z squared is equal to 4. And here z squared is equal to 1. So what I'm going to do is take the square root of both sides like so. And that gives me z is equal to plus or minus the square root of 4, which is 2. Here I'm going to take the square root. So z is equal to plus or minus 1. So I'd like you, if you could, turn on a calculator and see that if you do type in this equation, z to the fourth minus 5z squared plus 4, you will see that it does cross at plus or minus 2 and plus or minus 1. It has kind of a waviness to it, and also a y-intercept of 4. So without turning on my calculator, this is going to be negative 2, this is negative 1, this is 1, 2, 3, 4 right up here. So I'm going to put a dot up there for that y-intercept of 4, positive 1, and positive 2. So this graph is going to kind of have a waviness to it like so. And without actually looking at the screen, I can't tell you how far down it goes. I'm making just an estimate, but it could go down further. So it's kind of cool. You see that this this equation with the power of 4 had 4 answers. And basically the law of algebra says that, the fundamental law of algebra says that the power is going to tell you up to how many solutions the graph could have, or how many number of times it crosses the x-axis. So problem number 2, like problem number 1, I'm going to set u equal to x squared. That's going to make my first variable u squared, so I got negative 8. U minus 9 equals 0. This is factorable because I can multiply two numbers to make negative 9 and add to make negative 8. So these are my two answers here, 9 and 1. And if I, the 9 has to be negative. If I go x minus 9 equals 0, x plus 1 equals 0, I now have x equals 9. I got x equals negative 1. Now what's cool about that, now we get to see some real work in this section, because I'm going to, oh shoot, did you see me just accidentally switch back to x's? Oh, I'm so sorry about that. Okay, so this is the way it should have been written. U minus 9 and u plus 1 equals 0. So my u minus 9 is equal to 0, and u plus 1 is equal to 0. And now if I move my 9 to the other side, u is equal to 9, and u is equal to negative 1. So sorry about this, guys. I accidentally switched back into x's without thinking about it. So now, now that I'm at this stage, because I've done my first two steps, now I'm going to plug my middle variable back in for u. So x squared is equal to 9, and x squared is equal to negative 1. So if I take the square root of both sides, now x is equal to plus or minus, is equal to plus or minus 3. And in this case, I have imaginary answers, because if I take the square root, I'm going to have x is equal to plus or minus I. Because, you see, in this problem here, the square root of negative 1 is I. So if we were to graph this out, we would only see two real solutions, plus and minus 3, and we wouldn't see where this crosses, because it crosses an imaginary axis and has a y-intercept at negative 9. It's pretty cool to actually go back and take a look at these, but that's, you know, the fundamental law of algebra that says that if you have x to the 4th power, you will have up to 4 answers, and in this case we have 2 real answers and 2 imaginary answers. Well, there's 2 problems out of 6. So here we go with this problem here. And what we have is our u is going to be set equal to x to the 1/2 power. And as a reminder, the 1/2 power of x is the same thing as the square root of x. But this is going to make our u squared minus u, because u is going to be equal to the 1/2 power minus 20 equals 0. And well, what we're going to do is we're going to do some factoring, because there are two numbers that will multiply to make our negative 20, and add to make negative 1 in the case this first problem here. So now I've got u minus 5 equals, u minus 5 equals 0, which means u is going to be equal to 5, and I also have u plus 4 equals 0, which means u is equal to negative 4. Now what I'm about to do is plug my x to the 1/2 power back in for u. And x to the 1/2 power equals 5, or I could write that as the square root of x is equal to 5. Here I'm going to have the square root of x, or x to the 1/2 power, equals negative 4, or the square root of x is equal to negative 4. Now to get the x by itself, I'll square both sides, so x is equal to 25. So this graph is going to intersect 25, 0. And here, this is a paradox. Right there, the square root of any number will never be a negative. So this answer only has one real solution, and that answer is going to be 25. And if you take a look at the graph for this problem, you will see that it only intersects at 25, 0. And this is a non-solution, because no matter what you plug in for x, even a negative number will never give you a negative 4 once you take the square root. If you plug a negative in here, you'll get an imaginary number, but you'll never get a negative 4 for that problem. So this only has one real solution. I am going to plug u, let u equals x squared. What this is going to give me is it's going to give me a u, that doesn't look so good, u squared plus 4u minus 32 equals 0. And I can factor this. I can think of two numbers to make negative 32 and add to make 4. That's u plus 8, and then u minus 4, right? Because 8 times negative 4 is negative 32. And then add these together, make positive 4 equals 0. So what this is going to give me is it's going to give me u plus 8 equals 0. So u is equal to negative 8. And then u minus 4 is equal to 0. So u is equal to positive 4. Now I'm going to substitute my x squared in back for the u. So x squared is equal to negative 8. X squared is equal to 4. Take the square root of both sides. Here we go. And so in this case, this is going to be the square root of 8 can be broken into the square root of 4 times the square root of 2 times the square root of negative 1. So x is going to be equal to plus or minus 2 square root of 2i. And here, if I take the square root of both sides, x is going to be equal to plus or minus 2. So this power to the fourth equation is going to have two real solutions, plus or minus 2, and two imaginary solutions, plus or minus 2 square root of 2i, which we would not see because it crosses an imaginary imaginary horizontal line. So we would see the two real answers and the two imaginary answers for that problem. Okay, so for our final two problems here, both of which can be factored, which is great. So I've never used quadratic formula in this section here. I'm going to let u equal x squared. So here I have my u squared minus 6u, not I, 6u plus 8 equals 0. So I can figure out two numbers to multiply to make positive 8 and add to make negative 6. So that's negative 2, negative 4 equals 0. So x is going to be equal to 2 and x is going to be equal to 4. That's if I set those equal to 0 and moved them over. Take my x squared. Oh no! I did it again. I changed my variable to an x just for out of habit there. So these are technically u's, not x's. So I'm sorry about that. So this u minus 2, u minus 4. And now I'm going to plug my x squared back into u. So x squared is equal to 2. Here x squared is equal to 4. Take the square root of both sides. Here x is equal to plus or minus the square root of 2, which is a decimal. And here my x is, we'll take the square root. So x is equal to plus or minus 2. So this is going to have four solutions that are real, 2 rational and 2 irrational. This is a graph that is going to hit the ground at plus or minus 2. It's going to hit the ground at plus or minus square root of 2, which is 1.3 something or 1.4 something, don't know off the top of my head, and also has a y-intercept of 8. So this has this W-shaped look to it if you zoomed in far enough. So here are the four answers to this problem. Now for this problem, I got x to the fourth minus 1 equals 0. Yep, it's factorable. This is going to be, and in this case, I'm not actually even going to substitute anything at all. I'm just going to factor this out into x squared plus 1. X squared minus 1 equals 0. And this x squared plus 1, this doesn't factor anymore, but this can be factored into x plus 1, and x minus 1 equals 0. And this is going to give me some solutions here. I'm going to have my x squared plus 1 equals 0. If I solve for this, so this is my first set right here. I'm going to subtract 1 from both sides. So x squared is equal to negative 1. Take the square root of both sides. X is equal to plus or minus I. So I've got two solutions there. Here I'm going to have x plus 1 equals 0. So that's going to be x equals negative 1. There's nothing to square root here. Here I'm going to have my x minus 1 equals 0. So I'm going to add 1 to both sides. So x is equal to 1. So my answers to this problem are plus or minus I, negative 1, and 1. So this power to the fourth problem has four answers, 2 real, 1 and negative 1, and 2 imaginary, plus or minus I. All right, thank you for watching part 1 of this 3-part video talking about solving radical equations.